Hello students, in this video we will learn to find the sum of n terms of the AP. Now the sum of n terms of an AP is given by Sn equal to n by 2 into 2a plus n minus 1d, where a is the first term of the AP, d is the common difference, and n is the number of terms up to which we have to find its sum. Now this Sn equal to n upon 2 into 2a plus n minus 1d can be written as n upon 2 a plus n minus 1d. Here I have written 2a as a plus a. Now as we know that a plus n minus 1d is the formula to find the nth term of AP. So in place of a plus n minus 1d, we can write an. So in case we have to find the sum of the first n terms of the AP and nth term is given to us, then we can apply the formula as Sn equal to n by 2 a plus an to find its sum. Now if there are only n terms in the AP, then an will be the last term of the AP, and last term of the AP here I have taken as L. Then Sn can be written as n upon 2 a plus, and an was the last term, so in place of an we can write it as L. And then the sum of the n terms of the AP will given by Sn equal to n upon 2 into a plus L. Now come to exercise 5.3. Now here in first question we have to find the sum of the following APs. Now I am doing fourth part of it. In this AP is given to us as 1 upon 15, 1 upon 12, 1 upon 10, and we have to find its sum up to 11 terms. Here A1 or first term of the AP is 1 by 15, second term A2 is 1 by 12. First of all, we will find out the common difference of AP. Now common difference that we take as D will be equal to A2 minus A1. As you know that common difference of AP is the difference between the consecutive terms of AP. Now A2 is 1 upon 12 minus A1 is 1 by 15, and that will give us 1 by 60. So common difference of AP is 1 by 60. Now as we know, sum of n terms of AP is given by Sn equal to n upon 2 2a plus n minus 1d. So the sum of 11 terms of AP will be S11, and that will be equal to, now in place of n we have to take 11, that will 11 by 2 2a. Now 2a, a was the first term of AP and that was 15, 1 by 15. Now plus n, that was 11 again, 11 minus 1, and d we have got as 1 upon 60. Now this will give us the sum of 11 terms of the AP as 33 by 20. In question number 2, again we have to find the sums given below. Now in third part, we have to find the sum of minus 5, minus 8, minus 11 up to minus 230. Here the first term is minus 5, that we have taken as A1, second term is minus 8, and third term is minus 11. Also the last term is given to us as minus 230. As here it is not given to us in this question that whether these terms are in AP or not. So first of all we will prove that these are in AP. Now for that we will find the difference of the consecutive terms. Now A2 minus A1 is equal to minus 8 minus minus 5, and that is giving us result as minus 3, and A3 minus A2, that is minus 11 minus minus 8 is also equal to minus 3, as here a2 minus a1 is equal to a3 minus a2. So we can say that the terms minus 5, minus 8, minus 11 up to minus 230 are in AP. Now, after this we'll find out the common difference of the AP, that is D. D is equal to A2 minus A1. Now A2 minus A1 we have already find it, that was minus 3. Now, as we know that sum of n terms of AP is given by Sn equal to n upon 2 2a plus n minus 1d. Here first of all we need to find the value of n, as n is not given, number of terms is not given to us. So let us take that the number of terms in AP be n, then an will be the last term of the AP, that is L. Now formula for an was a plus n minus 1d, and that equal to L, and L here last term was minus 230. Now on putting the value of a and d that we have obtained earlier, value of a was minus 5 and d was minus 3, we can solve it for to get the value of n. Now value of n is coming as 76, so we can say there are 76 terms in an AP. Now sum of this AP, that is Sn, will be given by Sn equal to n by 2 a. Now here as last term of the AP is given to us, that is minus 230, so we can apply the formula of Sn as n upon 2 a plus L, and that will be value of n was 76, a was minus 5 and plus L was minus 230, and this will give us 38 into minus 5 minus 230, and our sum will be equal to minus 8930. In question number 3rd, in an AP, now a equal to 5, d equal to 3 and an equal to 50 is given to us. Now we have to find the value of n and Sn. As an is given to us, we will apply the formula for an to get the value of n. Now an is equal to 50 here, so we can, and formula for an is a plus n minus 1 d, and that is given to us equal to 50. Now here value of a is 5 and d is 3. 5 plus n minus 1 d was 3 here, equal to 50, and from this we can get the value of n, and the value of n will be equal to 16. Now here we also have to find the value of Sn. Sn will be equal to, as here the nth term of the AP is 50, so we can apply the formula of Sn as n upon 2 a plus an, and n was 16, a was given to us as 5 and an was 50, and that will be equal to 440. In part 5th of question number 3rd, D and S9 are given to us. We have to find the value of A and A9. Here S9 is given to us, so we will apply the formula of Sn here, and we will take n as 9. That will be Sn is equal to n upon 2 2a plus n minus 1d. So we can write S9 as 9 upon 2 2a plus 9 minus 1 d, and that is given to us as equal to 75, and this will be equal to 9 upon 2a plus 9 minus 1 will be equal to 8 into d, and d was given to us as 5. Now on solving this, we can find the value of a, and here the value of a is minus 35 by 3. Now we have to find the value of a9 here. Now as we know that a9 will be equal to a plus 9 minus 1 will be 8d. Now this is equal to minus 35 by 3, that was value of a, plus 8, and d was given to us as 5, and this will give us the value of a9 as 85 by 3. Now in 7th part of question number 3, a, an and sn are given to us. We have to find the value of n and d. Now as an and sn are given to us, and we know that sn is given by n by 2 a plus an if an is known, and that is equal to 210. Now n upon 2 a was given to us as 8 plus an was 62, and that is equal to 210, and this will give us value of n as 6. Now again we have to find out, next we have to find out the value of d, and an is given to us as 62, so we can apply the formula of an as a plus n minus 1d, and that will be equal to 62. Here value of a is given to us as 8, n we have obtained was equal to 6, and d that we have to get. Now this will give us d equal to an was 62 here. D will be equal to 62 minus 8 will be equal to 54 by 5. Now in 10th part of question number 3, L, S, and N are given to us. Now we have to find the value of A from here. Now as S is equal to 144, now the formula for S in terms of L will be equal to n by 2 A plus L, and that is equal to 144. Now on putting the value of n and L, n as 9 and L as 28, we can get the value of A, and here we are getting the value of A as 4. In question number 4, now we have to find out the number of terms in an AP 9, 17, 25 that must give us the sum as 636. Now here AP is given to us as 9, 17, 25 and so on. Now first of all we will find out its common difference, and common difference will be A2 minus A1. A2 is 17 here and A1 is 9, and that will give us a common difference as 8. Now this we have to find the number of terms whose sum is 636. So let the sum of n terms of AP is equal to 636. Now that means Sn will be equal to 636. Now Sn will be given by n upon 2 2a plus n minus 1d, and that was equal to 636. Now on putting the value of A and D, we are getting it as n by 2, 2 into 9 plus n minus 1 d, and d was 8 equal to 636. That will give us n by 2, 8n plus 10 equal to 636. as we know 8, 10 and 10 are both divisible by 2. So on dividing these by 2, we will get n into 4n plus 5 now equal to 636. This is giving us a quadratic equation 4n square plus 5n minus 636 equal to 0. Now we have read earlier the quadratic formula that x is equal to minus b plus minus under root b square minus 4ac upon 2a are the roots of the equation of a quadratic equation in variable x. So n will be equal to minus b. Here b means coefficient of n and coefficient of n is 5. That will be minus 5 plus minus under root again b square. B is again coefficient of n, that is 5. So 5 square minus 4 a was 4 here, coefficient of n square was 4, and into c constant term, and that is minus 636 upon 2 into a, and a was again 4 here. A will be coefficient of n square, b will be the coefficient of n, and c will be the constant term. Now on solving this, we are getting the value of n as minus 5 plus minus under root 10201 upon 8. Now this 10201 is square root of 101. Now on taking negative sign, we are getting n equal to minus 5 minus 101 upon 8, and that is equal to minus 53 upon 4, as the number of terms cannot be negative or in a fraction. So minus 53 upon 4 cannot be the value of n. Now on taking positive sign, this will be n will be equal to minus 5 plus 101 upon 8, and that is giving the value of n as 12. So this is our answer. Question number 9. If the sum of first 7 terms of an AP is 49 and that of 17 terms is 289, we have to find the sum of first n terms. Now here the first term and the common difference is not given to us, so we will take the first term of AP as A and common difference as D. Now sum of first 7 terms was equal to 49, that means S7 will be equal to 49. Now S7 from the formula, as we know, Sn equal to n upon 2, 2a plus n minus 1 d. So this S7 can be written as 7 upon 2, 2a plus 7 minus 1 d, and that was equal to 49. Now on solving this, we are getting an equation in two variables a and d, and that is a plus 3d equal to 7. Now again S17 is also given to us. Now sum of 17 terms will be given by 17 upon 2 into 2a plus 17 minus 1d, and that was equal to 289. Now this is again giving us an equation in a and d, and that is a plus 8d equal to 17. Now we can solve the equation first and second by substitution or elimination method to get the values of a and d. Here I am directly writing the values of a and d. You have to solve these two equations. Now here we are getting the value of a as 1 and d as 2. Now we have to find the value of sum of n terms of the AP. That will be Sn, and Sn is equal to n by 2, 2a plus n minus 1d. Here we will put the values of a and d to get the value of sum of n terms, and that is equal to n square. Now question number 10. So that a1, a2 up to an and so on form an AP where an is defined as below. Now two parts are given to us. Also find the sum of the 15 terms in each case. Now I am doing second part of it. Now an is equal to 9 minus 5n. From this we can find out the terms of the AP. A1 will be equal to 9 minus 5 into 1. Now in place of n we will take 1 and that is 4. Now similarly a2 will be 9 minus 5 into 2 and this will be 9 minus 10 that equal to minus 1. a3 will be equal to 9 minus 5 into 3 and that will be 9 minus 15 equal to minus 6. Now we have to prove that these a1, a2, a3 are in AP. Now here for that we will find out the difference between consecutive terms. A2 minus a1 will give us minus 1 minus 4 and that equal to minus 5. Similarly a3 minus a2 will be equal to minus 6 minus minus 1 and that will be again equal to minus 5, as here a2 minus a1 is equal to a3 minus a2. So this a1, a2, a3 are in AP. Now after proving that these terms are in AP, we have to find the sum of the first 15 terms. And in order to find the sum of the terms, first of all we will find out the common difference of AP. Now common difference D will be equal to a2 minus a1 and that we have already obtained as equal to minus 5. Now as Sn equal to sum of n terms is equal to n by 2 2a plus n minus 1d. So S15 we have to find the sum of first 15 terms will be equal to 15 by 2 into a, and a here was 4 plus n is 15. We have to find the sum of 15 terms and d is minus 5. Now we can solve it now to find out the sum of first 15 terms. Now in 11th question, if the sum of the first n terms of the AP is 4n minus n square, what is the first term, that is S1? What is the sum of first two terms? What is the second term? Similarly find the third, the 10th and the nth terms. First of all, the sum of n terms of an AP is Sn is given to us and that is 4n minus n square. Now we have to find out the first term of the AP. Now first term A1 will be equal to S1. That means A1 will be equal to S1 will be 4 into 1 minus 1 square. In place of n we will take 1 here and this will give us first term as 3. Now we have to find the sum of the two terms of the AP. The sum of first two terms of AP will be equal to S2 and S2 will be 4 into 2 minus 2 square on putting 2 in place of n in Sn, and that will be 8 minus 4 equal to 4. Now we have to find out the second term of the AP A2. Now see here, suppose there is any AP A1, A2, A3 and so on, and we have to find out the second term of the AP. Now second term of the AP can be obtained by the sum of first two terms of the AP, that means S2 minus the sum of first term of the AP, that means S1. Similarly, if we want to find the third term of the AP, now that can be obtained by first adding first three terms of the AP and that will be equal to S3 and then subtracting the sum of first two terms of the AP. Now here if A1, A2, A3 and so on are in AP and we want to find the third term of AP, then we can add the first three terms of AP, that means S3 and then subtract the sum of first two terms of the AP from here, that is S2, and that will give us A3. So similarly here we have to find A2. In order to find A2, we have to subtract S1 from S2. Now S2 we have already obtained as 4 minus S1. S1 and A1 were same, and that was 3. So A2 will be equal to 1. Similarly, sum of the first three terms of AP will be 4 into 3 minus 3 square, 12 minus 9, that will give us 3. Now if you want to find A3 or third term of AP, that will be sum of the first three terms of AP minus sum of first two terms of the AP. Now sum of first three terms of AP was 3 and sum of first two terms was 4, and that will give us the third term, that is minus 1. Similarly, we can find other terms of the AP. Now here we have to find the nth term of the AP. The nth term will be similarly as we have to find the third term as S3 minus S2. The nth term will be Sn minus sum of the terms before nth term, and that will be one term before nth term, that will be Sn minus 1. Now Sn is given to us, that was 4n minus n square. Now minus Sn minus 1. Now in Sn minus 1 we have to put n minus 1 in place of n. So that will be 4 into n minus 1 minus n square. N square means in place of n we have to take n minus 1. So that will be n minus 1 square. And this will give us 4n minus n square minus, this will be 4n minus 4 minus n square minus 2n plus 1. That will give us 4n minus n square minus 4n minus 4 minus n square plus 2n minus 1, and this will be equal to 4n minus n square minus, now this 4n plus 2n will be 6n, to minus 6n plus n square minus 4 minus 1 will be minus 5, and 1 minus outside here, so it will be plus 5, n square, and that will give us minus 2n plus 5. So this is our nth term. Now question number 12, 13 and 14 are similar questions. Now in 14th question we have to find the sum of odd numbers between 0 and 50. So odd numbers between 0 and 50 will be 1, 3, 5, 7 and so on up to 49, and then we can find its sum. Now here I am doing question number 13. Here we have to find the sum of first 15 multiples of 8. Now first 15 multiples of 8 will be 8 into 1 will be 8, 8 into 2 16, now 8 into 3 will be 24, 8 into 4 32 and so on up to 8 into 15, that will be 120. Now here we have to find its sum. As we see here, these are in AP and the common difference is D. D is 8 here, so we can say that A1 is 8, A2 is 16 here. Common difference D is A2 minus A1, and that is 16 minus 8 equal to 8. Now common difference will be 8 as these are the multiples of 8. Now we have to find the sum of 15 multiples. So here n will be 15. So S15 will be, now from the formula Sn equal to n upon 2. Here last term is known to us, so we will use the formula n upon 2 a plus l. So it will be 15 upon 2 a. A was 8 and L was 120, and solution of this will give us the sum of first 15 terms. In question number 15, a contract on construction job specifies a penalty of delay of completion beyond a certain date as follows: 200 for the first day, 250 for the second day, 300 for the third day, etc. The penalty for each succeeding day being rupees 50 more than the preceding day. How much money the contractor has to pay as penalty if he delayed the work for 30 days? Now here, penalty for first 3 days is rupees 200, 250 and rupees 300. Now it can be observed that these penalties are in AP having the common difference as 50, because difference between each consecutive penalty is of rupees 50. Now their first term is 200 and common difference is 50. So A is 200 and D is 50. Now penalty paid if the work is delayed by 30 days will be given by S30, and S30 will be equal to 30 by 2 into 2A plus 30 minus 1D. Now here we will put the values of A and D to get the total penalty paid. Now in question number 16, a sum of rupees 700 is to be used to give 7 cash prizes to students of the school for their overall academic performance. If each prize is rupees 20 less than the preceding prize, find the value of each of the prizes. Now let us suppose the cost of first prize be rupees A. Then the second prize will be 20 less than A, and that will be A minus 20. Third prizes will be 20 less than the second prize, that means A minus 20 minus 20, and that is A minus 40. Now it is observed here that the cost of these prizes are in AP. Now each prize is 20 rupees less than its preceding price, so their common difference is minus 20 and the first term is A. Now the total sum distributed is given to us in 7 prizes. Now there are number of prizes is 7 and total sum given in 7 prizes is rupees 700. So we can say that S7 is equal to 700. Now S7 will be 7 by 2 into 2A plus 7 minus 1 into D, and on putting the value of A and D we can get the value of A, and that was our first prize. Now so the value of each prices is given by A was 160. Now we will keep on decreasing 20 rupees to each prize, and that will give us the 7 prizes given. Now question number 17. In a school, students thought of planting trees in and around the school to reduce air pollution. It was decided that the number of trees that each section of each class will plant will be same as the class in which they are studying. Example, a section of class first will plant 1 tree, a section of class second will plant 2 trees, and so on until class 12. There are 3 sections in each class. How many trees will be planted by the students? The number of trees planted by students will be 3 into 1, 3 into 2, up to 3 into 12, as each class has 3 sections, and trees planted by class first will be equal to their class, that is 1. So 3 sections will plant 3 into 1 trees. Similarly, class second will plant 2, each section of class second will plant 2 trees, and there are 3 sections in all, so trees planted by second class will be 3 into 2, and we can find the trees planted by the other classes up to 12th class. Now it is giving us that trees planted are 3, 6, 9, 12 up to 36. These are in AP. Now first term of AP, A is 3. Common difference D will be 6 minus 3, that is 3 again. Now we have to find out total trees planted by the students. Now there are 12 classes, or you can say 12 terms in this AP. So we have to find S12, and S12 will be equal to n by 2 to A plus n minus 1D, where n is 12, A is 3 and D is 3. And all solving this, we will get the total trees planted by the student as 234. In 18th question, a spiral is made up of successive semicircles with centers alternately at A and B, starting with the center A of radius 0.5 cm, 1 cm, 1.5 cm, and so on. What is the total length of such spiral made by 13 consecutive semicircles? Here, radii of semicircles are given to us. R1 is 0.5 cm, R2 is 1 cm, R3 is 1.5 cm, and such and so on up to 13 semicircles. Now we have to find out the total length of the spiral. Total length of the spiral will be obtained by adding the semi-perimeters, or you can say perimeters of the semicircles. Now as we know that semi-perimeter of a circle is equal to pi r, so total length of the spiral will be equal to sum of the perimeters of semicircle, 13 semicircles, that is pi r1 plus pi r2 plus pi r3 up to pi r13. Now here pi is common in all the terms. On taking pi as common, we are getting r1 plus r2 plus r3 up to r13. R1 was 0.5, R2 was 1, R3 was 1.5 up to R13. Now as we see here, R1, R2, R3 up to R13 are in AP with A or first term as 0.5 and common difference D as 1 minus 0.5, that is again 0.5. Now so this S will be equal to therefore S will be equal to pi was common, into sum of the radii that are in AP. To sum of the 13 terms of AP will be 13 by 2 into 2A plus 13 minus 1 D. Here A is 0.5 and D is also 0.5. On putting the values of A and D, we will get the total length of the spiral, and that is 143 centimeter. 19th question. 200 logs are stacked in the following manner: 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. In how many rows are the 200 logs placed, and how many logs are in the top row? Now number of logs is 20, 19, 18 and so on, and these are in AP with their first term A equal to 20 and common difference D equal to 19 minus 20, that is minus 1. Now let the total of 200 logs, now total number of logs are given to us as 200, so let 200 logs be placed in n rows. If 200 logs are placed in n rows, then Sn should be equal to 200. Sn will be equal to n by 2 2a plus n minus 1d. Now on putting the value of a and d, we can get the value of n. Now here we are getting a quadratic equation in n, that is n square minus 41n plus 200 equal to 0. Now this will be equal to n square minus 16n minus 25n plus 400 equal to 0, and this will give us two factors as n minus 16 into n minus 25 equal to 0. Now multiple of two numbers is 0 if either one of them is 0. So if n minus 16 is 0, then n will be equal to 16. Or if n minus 25 is equal to 0, then n will be equal to 25. Now if n is equal to 16, then an, that equal to a plus n minus 1d, will be equal to 5. An is the number of logs in the top row, and that equal to 5 here. Now if n equal to 25, then an will be equal to minus 4, which is not possible as the number of logs in the top row cannot be equal to minus 4. Thus we can say that the number of rows is 16 and number of logs in the top row is equal to 5. In a potato race, a bucket is placed at a starting point which is 5 meters from the first potato. Here the distance of the first potato from the bucket is 5 meters and the other potatoes are placed 3 meters apart. That means distance between second and third potato is 3 meters, third and fourth potato is 3 meters, and also first and second potato is 3 meters. Now there are 10 potatoes in a line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drop it in the bucket, runs back to pick up the next potato, runs to the bucket to drop it in, and C continues in the same way until all the potatoes are in the bucket. What is the distance the competitor has to run? Now distance of the potatoes from the bucket are 5 meter, 8 meter, 11 meter, 14 meter, and so on is given to us. Now distance run by the competitor for collecting the potatoes are 2 times of the distance of potatoes, as the competitor has to run from the bucket to the potato, and then after picking the potato, C has to run back to the bucket. So C has to cover twice the distance of potatoes. Now therefore distances to be run will be 2 into 5, that will be 10, 2 into 8, 16, 22, 28. Now these distances are in AP with first term A equal to 10 and common difference D equal to 16 minus 10 equal to 6. Now total distance run for 10 potatoes will be the sum of the distances run for the potatoes, and there are 10 potatoes in all, so the sum of that will be equal to sum of the distances run to pick 10 potatoes, and that will be equal to 10 by 2, as number of potatoes is 10, so n will be 10 by 2 into 2a plus 10 minus 1d. Now here a is 10 and d is 6. On putting the value of a and d, we will get the total distance covered by the competitor, and that is 370 meter. Thank you.